Hi, today's lecture is about AppArmor and HTTPS protocol plus some hardening recommendations for Linux server. What is AppArmor? AppArmor is an effective and easy to use Linux security system. It's protect the operation system and application from external or internal threats, even zero-day attacks by enforcing good behavior and preventing both known and unknown application flaws from being exploited. AppArmor supplements the traditional Unix discretionary access control model by providing mandatory access control. It has been included in the mainline Linux kernel since version 2.6. In other words, AppArmor is a Linux software security mechanism that is very effective and user friendly, which secure the Linux operation system and apps from numerous attacks by implementing the security policies, which is commonly referred to as the profile. Profiles can allow capabilities like network access, raw socket access, and the permissions to read, write, or execute files on matching paths and so on. Many Linux distributions like Ubuntu, Debian, or others come with AppArmor installed by default. To check the AppArmor status on your machine, we can simply type in terminal AA-enabled, then hit the enter. Or to display the current loaded status, use AA-status, then hit the enter and see the result. What does profile look like? It is comprises simple text files which you can see on page 8 of this PowerPoint. The profile text file is compiled by the policy compiler or the AppArmor parser and loaded into the kernel where the security module, a Linux security module, enforce all kernel-based privileges. We have two functional modes, enforce mode, and complain mode. The AppArmor production status is in enforce mode by default, but the complaint mode is beneficial for logging violations and defining a rule set based on actual operation patterns. In contrast to being a component of the framework, AppArmor is an add-on feature that can be added, modified, disabled, or uninstalled. The modes can be switched from the specified modes of the profile. This means that the enforce mode can be changed with the complaint mode and vice versa. On this page, on page 8, you can find how to enable and disable the modes. Linux server hardening and security practice. Number one, use Secure Shell Protocol. Secure Shell Protocol or SSH enables a secure connection to your network service over an unsecured network. There are several default settings in the config file that need to be enabled to harden the SSH server operation. Each server should be configured to use SSH for Logging in remotely. Other protocols such as Telnet and rlogin transfer the password in plain text, which is leaving a big security hole. Configure IP tables to restrict SSH access from known IPs only. Use SSH version number 2 because of its security enhancements uh, over SSH version number 1. Consider disabling SSH, although if it is not needed. Key-based authentication should be used instead of password-based authentication. Number 2, close unnecessary open ports. Tools like Netstate, state will help to check which software is listening for incoming connections. If you find an unnecessary service or server application listening for inbound connection, disable the port or remove the application. Number three, enable firewall. Using Linux IP tables to keep a tab on incoming, outgoing, and forwarded practice uh, can help you secure your server. You can configure allow and deny rules to accept or send traffic from specific IP address. This restricts the unchecked traffic movement on your server. And number four, enable AppArmor or SE Linux. Modern Linux systems include the mandatory access control security enhancement system, AppArmor or SE Linux, installed by default to protect against the threats such as server misconfigurations, software vulnerabilities, and zero-day exploits, which could potentially compromise an entire system without these controls in place. Now let's little bit talk about HTTPS and see how it works and why it's important. HTTPS, which stands for Hypertext Transfer Protocol Secure, is an extension of the Hypertext Transfer Protocol HTTP. It uses encryption for secure communication over computer network and is widely used on the internet. In HTTPS, the communication protocol is encrypted using Transport Layer Security (TLS) or formerly Secure Socket Layer (SSL). The protocol is therefore also referred to as a HTTP over TLS or HTTP over SSL. This protocol secure communication by using what's known as an asymmetric public key infrastructure. This type of security system uses two different keys to encrypt communication between two parties, private key and public key. On this page, you can see the difference between HTTP and HTTPS, which is encrypted. This is before encryption and this is after encryption. So when information sent over the regular HTTP, the information is broken into packets of data that can be easily sniffed using free software. This makes communication over the unsecure medium, such as public Wi-Fi, highly vulnerable to interception. In fact, all communication that occur over HTTP in plain text, uh, making them highly accessible to anyone with the correct tools and vulnerable to on path. HTTPS and Internet Information Services. Since HTTPS is highly secure protocol, as mentioned, an IIS server offers several important benefits for website owners and the users. Um, some of them are as below: data encryption, as mentioned below, as mentioned before, encrypts the data exchange between the client and the server. Authentications, which means verify the identity of the server, assuring users that they are connected to the correct website. Protection from content injection, which means ensure the integrity of the content delivered to the user's browser. On most modern web browser, often they display a padlock icon on or a secure label in the addresses bar of HTTPS site, giving user cause that their connection is secure. Something like the picture of the above this page. So overall, using HTTPS on an IIS server is essential for securing data, establishing complying with the regulations, improving search engine optimization, and providing a better user experience. It's considered as a standard practice for any website, especially those that handle sensitive information or aim to build user trust and credibility. The use of HTTPS ensure that names, password, and other sensitive information cannot be deciphered as they are sent between web and the clients. HTTPS on Apache. Using HTTPS on an Apache web server is important for many of the same reasons as it is important on IIS server or any other web server. Again, here is why you should use HTTPS on an Apache server. Data encryptions, which means encrypt the data exchange between the client and the server. Authentication, which means verifies the identity of the server, assuring users that they are connecting to the correct website. Protecting from content injection, which means ensure the integrity of the content delivered to the user's browser. Also, again, the modern web browser often display a padlock icon or secure label on the URL bar. Um, Using HTTPS on an Apache server is crucial for securing data, establishing trust, complying with regulations, improving SEO, and providing a better user experience. It is considered a standard practice for any website, especially those that handle sensitive information or aim to build user trust and credibility. You can enable the HTTPS on an Apache server by obtaining an SSL TLS certificate and configuring your server to use it.